Welcome everybody. This is B Crow at X Producer B coming to you today with another video in our MIDI scripting series. Today we're going to be talking all about system exclusive messages. So without any further ado, let's go ahead and dive right in. So the last time we left off, we had built a small program in Python. And so what this is, we talked about MIDI, built a small program in Python to interact with MIDI using Python. And we're using packages. One of them is called E02 here, or E02, and the other one's called Python RT MIDI. Hopefully you were able to get those installed. And then the other one is in our main script here. We just wrote some very simple code classes here to deal with this. So before we get started into system exclusive, let me do a sort of overview about Python and its classes to kind of tell you how the language works. Of course, Python is a white space language, meaning that tabs or spaces delimitate the different scopes in the programming language. And to create a class, you just say class and then the MIDI message. And then this init method is the constructor of the class. That means it is the first method that is called when you create a new object from this class. A class is like a description of an object you want to create. Say if you have a person, that would be a person class. And when you want to instantiate that object, you could create a new class to represent me. My name is B Crow, so you'd have a name there. In this case, we have a class that's called a MIDI message, and it takes in a message that comes in from E02. And basically, I just have some methods here. It has a bytes attribute, the message type, the channel, the ID, and the value. And I'm getting all of that from the bytes. So that's the MIDI class. It's just really a helper for us to go through. Then I also created some functions to help me to choose and input and output MIDI ports, because each device that's plugged into your computer communicates over MIDI via ports. Even if it's USB, the USB is actually encapsulating a MIDI port on the inside. So they treat it just like MIDI ports. Okay. And so for each, I have a function called, and in Python, to start a function, you use the word def, or to define. Then you give the name of the function, and then you choose the attributes or arguments you want to pass into that function. And what we're doing is here, we're getting the output ports, and we're starting off with a found the port equals false, and then we're going to instantiate an out port index, an integer. That's what that is. This is a type def, if you will. And then we're just going to enumerate or loop over all of the ports and display them out. And if we found the one that you gave us, we're just going to say, yeah, we found it, and set the output to the index, break out of the loop, which will bring us into the next portion. If we did not find the port, so the port found is false, we're going to print all of those ports out with the index and allow you the opportunity to choose that port. And so, and then once you choose that port, we're going to open the port that you chose and print a statement to the console telling the user that we've opened the port. So very simple code here to open the port and then return it. So what we can do, instead of having to choose the port every time, I can actually just call the program. And then I can copy this port, because I'm still using the MPC Studio Public. So I just want to copy that. And as I go down here, I can pass that in. So the next time I run this, I shouldn't have to put the port name in, because it'll find it for me. Well, it's supposed to find it for me. Now you didn't want to find it. Set output index. Let's see. Where are we at? That's 4 again. Yeah. MIDI port name, MPC Studio Mk2 public. Oh, I didn't save that. That's why I didn't choose. I needed to save it. I'm going too fast for myself. There we go. All right. So we have the code here. We're able to choose the port. Okay. And then what we created last time was a very simple loop. Now this is specific to the package E02. Not all programs will work like this. Once you get into scripting environments with, say, FL Studio or Ableton Live, they have a different method for receiving incoming MIDI messages, and we'll get into that. But the principles are still the same. You're going to get messages that come in, and we're going to loop over. That's what a for is, for message in these ports. And then it's going to give us a message, and we can do things with these messages and respond to them as they are coming in. Okay. And so last time we created a simple program that, let me switch over to the overhead. Simple program that when we launch it in, we are listening for note on messages, and we were responding back with control change messages that corresponded with the ID of the note that came in. And that shows us that this device, these buttons on here, the LED buttons, are actually lit up using control change messages that correspond with the ID of the note message it sends. Remember, MIDI sends different types of messages. It sends note on messages, note off messages, and then control change messages. We also dealt with, I think, a aftertouch last time, and there are pitch bend, and there are some other types. But today, what I want to do is I want to talk about system exclusive messages, because much of the functionality that cannot be achieved over regular MIDI messages, the vendors or these manufacturers will use what's called system exclusive. And it is probably the trickiest type because there is no standard. There's only a couple of standardized messages types to send, and that those are mainly identification message, meaning that most MIDI devices, if you can send what's called a system exclusive identification message, and it will respond back with ID information for the device. Vendors use this to be able to properly identify a device before they send any messages further. So, but that's the only standard. Everything else concerning system exclusive is vendor specific, meaning that Akai can choose to do it one way. And Novation, maybe they can choose to do it another way. All right. And whoever makes your MIDI controller, M Audio, they can implement these system exclusive messages however they decide. So they're tricky to decipher, but they also introduce powerful capabilities to a MIDI device. And this MPC Studio right here, Mk2, is no different from that. It's largely controlled over system exclusive. So what I did to figure out how that worked, some people called me a hack, and I didn't really reverse engineer. I was like, oh, you don't really know what's going on behind the scenes. In order to capture that information, I had to open up a packet capture to capture the information that came from the MPC Studio software to this device, because the private port is blocked by the Akai MIDI driver. So I had to get a USB packet capture and capture the raw data and break it down in Wireshark to only show me the system exclusive, and then kind of look at patterns in the system exclusive messages that correlated to what was happening in the software due to timing indicators when those messages were sent. And then I could come up with patterns that I saw that clearly showed me what was happening. So I took all that information that I found, and for your benefit and for whoever's watching this, there is a public GitHub repository that I'd like to show you now. Let me close this other stuff out so you don't get spamming me. This is, let me show you the screen now. There we go. This is, well, let's do just the screen. Blow it up so you can see it on the video. There we go. So this is the information that I found. Okay. And the stuff up here is what we've already talked about. This is the buttons and all of their corresponding IDs and the CC values that they respond to. We dealt with that already. We haven't talked about the touch strip yet, but you can go and look at these things. Today, I want to focus on the system exclusive because there's a breakdown. So what is common about every system exclusive message is that it starts with a particular byte and then it ends with a particular byte. Okay. And every message starts with what is listed over here as F0. And then every message ends with what is listed down here at the end as F7. Okay. What is in the middle is largely up to the manufacturer to determine. However, there is a pattern that you'll recognize with most system exclusive messages is that after the start byte, they'll normally have some sort of ID information to identify the device itself. In this case, there's a manufacturer ID, there's a device ID, and there's a model ID. And I found that every message that was sent back and forth in between MPC Studio or MPC software and the controller began with the message start, F0, and then these 3 bytes afterwards, showing me that this identified properly this device. Okay. And the next byte, remember all this is still hexadecimal. Remember that 16 character format to represent numbers we talked about last video. That's what this is. The next byte in the process, according to the diagram here, is a message type. So what type of command or message are we sending to this controller? And I found out that every time that it colored pads, it sent this byte right here, 665 in hexadecimal. Okay. And then I noticed a pattern. After that, it would use 2 bytes to show the data length. And what is that? What this means is that these 2 bytes represent how big the payload is for the remaining bytes in this message. So because I have a pad numbers, 1 byte, I have a red, another byte, I have a green, another byte, and I have a blue, another byte. That's a total of 4 bytes. So it gives you 2 bytes to show that data using what's called MSB and LSB, basically most significant byte to least significant byte. That's a fancy term to mean we're taking 2 bytes in order to represent a number that is larger than 127. Because remember, MIDI values can only send data that is between 0 and 127. So if I need to send numbers that are larger than 127, I have to actually combine those, break it up into 2 bytes and combine those when I interpret it. Okay. And we'll look at how that happens in the Python code. So what this shows me is that I'm sending a command to color the pad. Okay. And it's going to be 4 bytes long. And this is the pad number. Now remember, in code, 0 is actually 1. You just got to get that in your head when you look at 0. So what this means is that I'm going to color pad number 1. And I have 3 values I can do. I can go red, I can go green, I can go blue, and I can go from 0 to 127. So using those 3 RGB values, you can represent most colors in the color spectrum, and you can represent them from 0 to 127. So what this is showing me, this message, I'll break it down. This is a system exclusive message, and this is meant for the MPC Studio Mk2 using these various IDs. And the message type is 65 hexadecimal, which means we're going to set a pad color, and it's going to be 4 bytes long. Okay. And then it's going to be pad 0, and we're going to set it to what looks like just red here. All right. So let's go through the process of implementing this in the Python code. So I'm just going to take this code, I'm going to copy it, and I'm going to go into my code here and just kind of paste it as a comment. Uh-oh, it didn't paste right. Hold on a second. Let's try that again. Copy. I have to blow this up so you guys can see it. Okay. So here is my. There we go. I'll make it really big. I don't need that right now. There we go. So hopefully you can see that there. All right. So this is my system exclusive message here. And what I did is I've already created the function to build a system exclusive message. All right. Look at here. I've got constants defined. Well, kind of constants. Python doesn't really have the concept of a constant just yet. We'll talk about that another time. But basically I've got constants defined up here. System start byte, sysx start. This is the manufacturer ID, the category ID, and the product ID. And I even have a message type, which is the pad color. That should be 65, I think it was. Yeah, it's device is 65. Okay, good. So the message type is pad color, all right, and then 65, and then I have the end byte. I don't think I'll use those, but I have them here in case I need them already defined. And I've already made what I call a header, because every message is going to start with the same 3 bytes. All right, so I just took those. A header is a tuple of manufacturer ID, category ID, and product ID. So I don't have to code that every time. It just helps me to be more concise. And I encourage you to put these constant values that don't change. Just put them in somewhere in your code, normally in a file where you can, that way you can reference them. And if they need to change, you only change them in one location. All right. So now I have this function here that says send sysx message, and I'm going to take in the message ID. This is my own code here. And the message ID will be the pad color, and then the payload will be the pad number and the RGB values. And what I'm doing is I'm making sure that it's a tuple. Okay. If it's not, I'm going to make it a tuple myself. All right. And then I'm going to take the message length, right? So what this is going to do is going to figure out how many bytes are in this message. Okay. And it's going to separate them into that MSB, LSB, like I was saying earlier. So I have some code here, and this is actually the code to separate it. You can do this using bitwise operation, and that might actually be faster performance-wise. Normally when I implement it, I do bitwise, but this time this is old code. So here it is. This is the message length, and what it's going to do, it's going to return those values that we looked at earlier. It's going to return these two right here, 0, 4. So if it's 4 bytes long, it'll return that for me, and it'll append it to the message. So then it's going to build it for me. So it's going to take my header, those 3 bytes. It's going to take my message ID, that 1 byte that I passed in. It's going to take the length that I just calculated. Then it's going to append the payload, which is whatever color that I want to send. All right. And so what's happening now is that we should be able to just code it out. So send sysx message. Okay. The type is going to be pad color. Okay. And let's see. We're going to color, let's say pad 0, which is going to be, should be this pad right here. Let me get the overhead going. This pad right here. All right, that should be it. All right, pad 0, and I'm going to send 127, which will turn fully red, and all the rest of them are going to be zeros. Let's see if it works or if it blows up in our face. See what we get. All right, boom. See, look, it's red. Awesome. So I can go, and it'll stay red until I change it again. Let's make it, put the red there. 127. All right, let's say I want to send green. RG. Let's say 127. We'll set red to 0. Let's try it again. We'll play with it a little bit. Okay, now we got green. All right. Now we're sending system exclusive messages. All right. So let's send, just for good measure, let's send blue. All right, now I run it again. We got blue. All right, so let's have some fun with this. Remember on the last video, we said that, and we learned that MIDI communicates everything that it does over bytes. It sends different types of messages. It sends note on messages, note off messages, controller change messages, and those are pretty the aftertouch messages, and those are the ones that really communicate what's going on with the controller. So if I press something, I can get a note value. Each one of these pads has a note value, and if you look on the screen, if I press pad 1, it is ID 37, and pad 2 is 36, and 42, and 82. So I can actually build a map to what pad corresponds to what ID just by observing what's coming in. All right, so let's actually do that. Let's create a note to ID map. All right, so we'll call it note ID map, and we'll just we'll use a map actually here. All right, okay. Look at auto. It's gonna try to do it for me, but that's not. Copilot thinks I want to do something different. Okay, so pad 0, right? Okay, excuse me. The first pad right here is 37, and it corresponds to pad 0x00. Okay, all right. Let's just use decibels. We don't have to use hexadecimal. We use just use 0. All right, that's pad 1. All right, the second one, 36, corresponds to pad 2, which, remember, 0 is 1, 1 is 2. All right, the next one is 42, pad 2. The next one is, I don't know why they jumped to 82, but it's 82. All right, that's pad 4. All right, now we go to the next row. This one is 40. It's got, all right, the next one right here. I'm sorry, let me show you the overhead when I'm pressing here. The next one right here, this is 38. So let's go. 38 is 5. This one right here we're seeing come through as 46 is 6. I think it's starting to pick up the pattern. The next one is 44. It's 7. Let's go up a row. The next one is going to be this one is 48. It's 8. All right. This one is 48, 47. 47. This one is 45. Don't ask me why Akai didn't why Akai numbered their pads like this. I'm sure it has something to do with the legacy software. I just don't know what it is. All right, the next one is 43. It's 11. All right, now this one is 49. 12. All right. Next one is 55. It is 13. We got 2 more. Next one's 51. It's 14. Next one is 53, 15. Okay, so there are all 16 pads. Remember, 0 starts at 1. So what I can do with this now is I can build a correlation between the note that I press and the pad number. All right, so let's actually do that in our code. For each message that comes in this port, if the MIDI is note, we're going to delete all of that. All right, note on or note off. I'm going to say pad number equals note ID map dot get message ID, and if it doesn't find it, it's going to be none, but I don't think it's going to find it. We're just going to print the pad number. All right, so print the pad number along with the MIDI message. Let's see what we get. No, I don't want to enable dictation. All right, let's try it. Okay, pad number 0, 1, 2. All right. All right, let's make it more readable. That way we can know. Don't have to do math in our head. Pad number +1. All right. So here we go. Pad number +1. Let's see what we got there. Uh-oh. Didn't do anything. Oh, I opened up MPC Studio. There we go. Turn that off. All right. The irony in that. All right, let's see what we got. I'll put on the overhead. So there we go. It shows me the pad numbers now on the screen. So now I have a map built of the pad numbers. Okay. Now what I can do is this. Since I know the pad number that correlates to the note, I can now send the color as I'm pressing the pad. Because remember, each time I press a pad, it also doesn't just send the note, it sends how hard I'm pressing it. And I can in turn send that back to the pad to tell it what color to play and how bright to play it. So watch this. We're going to say send sysx. We're going to give it the message pad color, and then we're going to give it the pad number. Okay. And then we're going to give it not just what color I want, but I'm going to take the note value. So MIDI message dot value, and it will in the red area. All right. Because remember, the note sends between, sorry, I didn't have my screen showing. The note sends between 0 and 127. So let's go over that again. I'm sending in this system exclusive message, I'm sending the pad color. All right. Then I'm sending the pad number, and I'm taking the note value and I'm resending that back to the device as the value for how bright I want the red color to be. All right. And so what that should do, if I press it hard, it'll show it hard. It'll show it bright. If I press it soft, it should show it bright. And when I do an off message, it shouldn't show it at all. So what we should see is the pad should start to respond with color to what we're playing. So let's close that out. Let's reload the program. See what we got. There it is. Overhead. Boom. There you go. So notice that it's completely lighting up. All right. If I press it soft, it lights up soft. If I press it hard, it lights up a lot. And if I release, it goes off. All right. So now you get how we can use System Exclusive to accomplish some pretty complicated, or what may seem like a complicated thing to do. It turns out not to be as complicated as you might think. All you need to do is find the mapping. Okay. The most complicated part is to figure out how these devices are sending the system exclusive messages over and what it means. But if you have that information, you can, through the code, cause the device to do some very clever things. Okay, and cause it to respond. So now we are armed with the information that we need to light this whole device. We can control the pad colors. We can control the button colors. We know what note value they respond to, and we know what control change values that they respond to. So what it does, it enables us now to really go into the code and to make some decisions as to how we want the device to respond. Okay. And the way you would implement this in any scripting environment, it is basically what I'm going to call, and what computer science degrees and call an observer pattern. So what does that mean? An observer pattern is basically just a fancy term to represent a observer and a respond, or a publisher and a subscribe. Basically, when something happens, something else should happen. All right. An observer pattern is a pattern of programming where you can respond to events that take place in a software application or in a hardware application. For example, we would want to, maybe an observer pattern would say, when I press the play button, I want this to happen. Okay. Notice that when I press play button, this one lit up because play button corresponds on note number 82, and so did this pad. So it doesn't know that I'm pressing a play button because they're coming on different channels. Okay, the pad communicates on channel 9, so the play button communicates on channel 0. But our code doesn't allow for that right now. Okay, but it suffices to say that if I want to respond to, when I press the play button, maybe I want the program to play. So how I would code that is, when the message comes in from channel 0 with ID 82 with a value of 127, I want to launch the function of play in Ableton Live. Okay. Or it could go the opposite way. I could say in Ableton Live, when the song is playing, when it starts to play, I want to capture that event and then send a value to the controller to light up the play LED. That way, when live is playing, it's going to send a value of 127 to the controller on control change 82. That will light this LED. When it is not playing, it will send a value of maybe 0 to turn the LED off. That way, you could use that observer pattern to have a visible representation of the state of the application on your controller. using those events. That's the majority of MIDI scripting, is using the observer pattern to respond to user interfaces, and then the hardware interface. And using that, you can control it, and have different things come in and come out. And these environments, these scripting environments, they do a lot to give you some tools to work with, so you're not left having to code everything from scratch. And I'll show you that next time when we get into, we're going to start with, I think FL Studio is a good place to start. So stay tuned for the next video. We're going to launch into the basics of coding in Python and FL Studio. And then I think the third video will launch into some basics of coding in Ableton Live. And here's what we're going to do. I'm going to take a controller, and we're going to program some basic functions inside of those programs live on these videos, and you're going to be able to do it with me, and you'll see how we overcome some of the hurdles, and we see how we can troubleshoot and do some error debugging as well as we go along the way, because I'm going to make plenty of mistakes like I always do, but I think it's going to be helpful so you guys can learn. All right. If you like this video, go ahead and subscribe to the channel. I'm putting all of these in a playlist, and this will be episode number 2, so you'll be able to follow along. Hope to see you guys soon. If you want any of these scripts that I've already made, go to xproducerb.com. I just released a script recently with the MPC Studio Black, and I have the screen working. It's amazing how that came to pass, and it really is powerful hardware to use with Ableton Live version 12. So subscribe to the channel. Go check out the website if you want. Look forward to seeing you guys soon. All right, until next time, deuces.